All right, sorry the video got cut off. I'm still on page 93. I'm going to show you the example down here now. All right, this one says you're basically doing the same thing, making this figure symmetrical on this side of HI. So I'm going to think of this one a little bit differently than this one. This one's just like straight across, kind of easy to do. This one's not. So I'm going to visualize what this is going to look like by thinking about if I were to fold along HI, what that would look like. So obviously you can't see the other side of my paper, but if I were to fold this way, this shape would be going up this way a little bit more. It wouldn't be like directly across like this one did. So without a protractor, this is kind of difficult. I just expect you to do the best you can. Mine's not going to be perfect either. That's okay. So I'm actually going to start with this line segment right here. I think that'll kind of help me get started with this figure. So I'm using my construction paper again. I want to first measure the distance L is from HI. So I'm gonna mark it. With my construction paper, I've lined up along this line, and then I'm gonna measure from the edge of my paper to right here. So that's where, oopsies, that's where I would plot this point L directly across. So again, I'm lining up. This is lined up with L, but from here I have where I stopped. This is the distance from L to HI on this side. So I can just, since I'm straight across here, I can plot L. Plot L right here. Okay, that's just one point. We still need to make our lines. So now I'm gonna go ahead and connect I to what was L. So I'm gonna measure IL right now. So these two will get connected now with what I just measured. All right, now let's talk about LK. So it kind of goes down. This one's gonna be a little tricky, this part. This part's pretty easy, but this isn't gonna look exactly the same because we don't have protractors, but let's try it. All right, I'm gonna measure LK now. All right, LK is this long. I could also measure it from HI if I wanted to, and then I could make that over here. This is a little bit extra step. So again, I'm aligning it along HI here. My point K is right here. All right, I'm gonna do a little dot to show where that's where it's gonna be. Okay. All right, first let's draw this one over here. This is kind of gonna be trial and error. I don't know. It looks okay. Let's try KJ. It's going to be going up this way. And then lastly, this line here. I mean, it should just connect, but let's just measure in case. So H to J. Yeah, looks like I'm pretty good. Not too bad, not exact, but pretty good without a ruler. Oopsie, it's not going this way though. I have to connect it to H. Okay, so you know, this doesn't look perfect. If I had a protractor, I could get all the angles right. I just want to see that you guys are using a ruler, trying to make it as symmetric as you can. All right, let's move on to page 94. All right, it says complete the following construction in the space below. Plot 3 non-collinear points D, E, and F. Okay, when they say this 3 co-nonlinear, that means they're not going to all lie on the same line. So we're drawing a line segment DE, a line segment EF, and a line DF. And then for the last one, it says plot G, draw the remaining sides such that the quadrilateral DEF is symmetric about DF. All right, I'm just gonna focus on A and B right now. We'll deal with C in a little while. So they want me to make these 3 points, D, E, and F. I can really draw them wherever I want. I'll call this one D. This one we'll call E, and over here we'll have F. All right, DE is a line segment. EF is a line segment. And then DF is a line, which means it's going to extend beyond the points. Okay, next they want us to plot G and draw the remaining sides such that the quadrilateral DEFG is symmetric about DF. Okay, so basically what they're saying is that they want us to plot another point over here. So when I plot that point, then these lines will get connected and it'll form a quadrilateral. But they also want it to be symmetric. So point G is going to have to be the same as point E across here because E is the middle. So I'm basically going to be making kind of like a kite. But it needs to be, of course, symmetrical, just like a kite is. So E will be somewhere around, or I'm sorry, G will be somewhere around here, and then I'll connect the points. So I'm gonna measure the distance E is from DF. Okay, so it's about that distance, which means, oops, yeah, which means point G is gonna be the same over on this side. And again, I'm gonna line it up so I'm actually getting it right. Okay, so this is where it ended. I'm gonna plot G about right there. And then I need to connect these points. Okay, that looks symmetrical to me, pretty good. All right, let's look at number 4. It says, Stu says that quadrilateral HIJK, so it's this quadrilateral, is symmetric about HJ because IL equals LK. Okay, so IL is right here. LK is here. And it says, use your tools to determine Stu's mistake. Explain your thinking. Okay, so first I'm gonna check if Stu is actually right. Let's see if IL is actually symmetric, you know, it'd basically be the same length. Okay, so that is how long this is. Those are the same length. So these do equal. He's right. But he's made a couple more errors. If you notice, he is saying that this 3 centimeters is equal to this 3 centimeters. Those are not the same. Also, this is not the same length as, so JI is not the same length as JK. Again, I don't have a ruler, but I'm gonna check this with my handy dandy construction paper. So IJ is this long. When I measure JK, it is way shorter. So IJ was this long, all the way to here, whereas JK is only down here. That is going to make the angles different too. So there's a way that I can explain this that would talk about the angle measurements. However, we're not measuring angles because we don't have protractors. So I'm just going to talk about the length of IJ and JK. Those are not the same. So this can't be symmetrical, because if they were symmetrical, those would be the same length, and IH and KH would also be. So why don't we actually measure that too to compare. Here is the length of IH. So this right here would have been IH. This whole thing is HK. So can't be symmetrical because of those side lengths. I will write the explanation here. You can see it in the answer key in the slides for today.